This demonstration is going to show us the difference between AC electricity and DC electricity. AC electricity stands for alternating current, and DC electricity stands for direct current. But before we talk about either of those, just a quick reminder that current is when electrons are moving. So when we turn on a light bulb, we have a current moving through the light bulb, and that current, all of those electrons that move through the bulb, will cause the filament to heat up until it starts glowing, which is what you want a light bulb to do. But the difference between AC and DC is that DC, direct current, has the electrons moving in one direction through the bulb the entire time. But if we use an alternating current, instead of having the electrons flow in one way, we have them switching back and forth, changing directions 60 times every second, or a frequency of 60 hertz. With this light bulb, I'm going to be able to show you the difference using this magnet. Ordinarily, the light bulb has nothing going on. It is not attracted or repelled from our magnet because the filament inside the light bulb isn't magnetic. But when we turn this on and we have current moving through the light bulb, that current is going to create a magnetic field all around there, because magnetic fields are created by moving electrical charges, and since a current is just a bunch of moving electrical charges, it creates a magnetic field. So we can see the light, but we're going to go ahead and dim the lights in the room to make this even more obvious. So when I pick up my magnet, I've got this light bulb set on direct current at the moment, and so when I move the magnet around, you can see it kind of being attracted or repelled from the magnet. The filament inside moves just a little bit. That's because on direct current, all of those electrons are moving in one direction, which means that they're creating a magnetic field that stays pretty much the same the entire time. So when I push it or pull it with the magnet, it does one thing and that's it. But when I switch this over, and we use alternating current, the light bulb itself looks the exact same right now. That's because it doesn't matter if we've got direct current or alternating current. As long as electrons are moving through that filament, it's going to glow and give off light and always look the same. But now when I get the magnet nearer, we can see the filament starting to shake, and it's vibrating back and forth. And it's vibrating back and forth because the current alternates. The current changes direction 60 times every second. And so when I get the magnet near it, the magnetic field created by our moving electrons switches direction 60 times every second. It alternates back and forth with the current, which causes it to change whether it's being attracted or repelled from our magnet, which means that it vibrates back and forth and gives us a very different looking appearance than the direct current. So the alternating current changes direction 60 times per second, which means that it's switching between being attracted and repelled, which means that every time it switches, it gets shaken back and forth, and it's shaking back and forth so fast that to the naked eye, it almost just looks like a blur. But on direct current, it doesn't shake. It moves just a little bit because it will still be attracted or repelled from the magnet, but since the current's not changing directions, it's not getting vibrated back and forth inside the bulb.